Well, hello students. This is Coach Holliday, and today we're solving radical equations. A radical equation is just a simple equation that has a square root or a cube root or something to a fraction of a power, like x to the 1/2 or x to the 2/3, something like that. And we're going to solve these exactly like you solve normal equations, like we did all year, except for at the end when we have the square root, we're going to just square it, or if we have a cube root, we're going to cube it. So it's easy as that. We're going to do this by performing inverse operations. So for example, if I have x plus 2 equals 5, the inverse operation of that is subtracting 2. Okay, hopefully everybody remembers how to do that. If I have x times 2, then I would divide by 2. If I have x minus 2, I would add 2. If I have the square root of x, I would square it. If I have the cube root of x, I would cube it. Okay? Pretty simple there. All right. Let's just go through what the steps for solving a radical equation are. All right? The first is to get the radical by itself. That's the first step. You're going to write these in your notes. The second step is to raise both sides of the equation to the power of the radical. That's after you've gotten the radical by itself. You're going to raise both sides to the power of the radical. And then the last step is you're just going to simplify that. Once that radical's gone, you're going to simplify it and solve them like you normally do, just getting the variable by itself. Okay? So you might want to pause this for just a moment and make sure you write all those things down before we jump right into our examples. All right, if you're ready, here we go. Here's the first example. This is on your paper. And if you'll see, this is the square root of x minus 12, and that's going to equal 9. Now, the first step said for us to get the radical by itself. Well, if you'll notice, the radical is by itself. Our radical, this side, is just all the radicals, so it's all by itself. All right, the second step is it said raise both sides to the power of the radical. Now, since there's no number there, we can always write a 2 in there for our radicals. This is a square root. So what we're going to do is we're going to raise this whole side to the second power. We're going to raise this whole side to the second power. Now, when I raise a square root to the power of 2, those cancel out, and I'm just left with x minus 12. On the right, 9 squared, if you have to use your calculator, can, but you shouldn't need it, is 81. And now I'm just going to solve this. The third step is simplify and solve. So I'm going to add 12 to both sides so that I can get that x by itself. That's the inverse operation of subtraction, is adding. And I get x equals 93. And there's my answer. All right? If you didn't understand that, rewind and look back at this again, okay? Any questions? Hopefully you're good there. Let's move on to example 2. Okay, example 2, we have a cube root here. All right, so we're going to have to cube things to get rid of the radical. So let's put this, let's cube both sides. Cube both sides. And that cube and the cube root will cancel, and that leaves me with 2x plus 1 equals 3 to the third power means 3 times 3 times 3, right? 3 times 3 is 9. 9 times 3 is 27. So I have equals 27. And now let's just solve this equation the way it is. We'll solve it for x. So I subtract 1 from both sides, subtract 1 from both sides. That gives me 2x equals 26. And then if I divide both sides by 2, that gives me x equals 13. So x is 13. I can plug that 13 back in for x up here and check my answer. I'd have 2 times 13 plus 1. 2 times 13 is 26, plus 1 is 27, and I have to take the cube root of that. The cube root of 27 is 3 times 3 times 3, that makes 27, so the cube root of 27 is 3, and that's what I wanted it to be. Okay, so that's example 2. Let's move on to example 3. If you'll notice, example 3 is another one of the cube roots, but you notice I have the cube root on both sides. So that's going to be something that works out even a little bit better for us. All right, so here we go. To get rid of this, since this side, the left side, is already solved for the cube root, I'm going to go ahead and cube it. All right, so I'm going to cube this side, and I'm going to cube the right side also. And when I cube both sides, on this side the cube and the cube root cancel, and it gives me x plus 6. On the right side, now notice, this cube will go actually to the 2 and the cube root. So I have to cube the 2 as well as cubing the cube root part. So 2 cubed is 2 times 2 times 2, which is 8. And I have to multiply that by, after I take the cube of the cube root, that x minus 1. So hopefully you see that 2 I have to cube, and then I have to cube the cube root of x minus 1. Then I'll just go ahead and solve this. I'll distribute and get 8x minus 8, and that's x plus 6 on the left. Now I'll solve this for x. I need to get my x's all on the same side. I'm going to move them to the left side. Oops, minus 8x, not minus 7x. Minus 8x. Those cancel. On the left, I get x minus 7. 8x is negative 7x plus 6 equals my negative 8. And then I'll subtract 6 from both sides. And that gives me negative 7x equals negative 14. And then the last step is to divide both sides by negative 7. And that gives me, I'm going to put my answer up here to the top, and that's going to give me x equals 2. I can check this by plugging the 2 in to this x and this x. So I'm going to go ahead and do that real quick. So I have the cube root of, I'm going to put the 2 in for x. 2 plus 6 is 8 equals 2 times the cube root. Put my 2 in for x. 2 minus 1 is just 1. Now the cube root of 8, you can do that in your calculator if you want, but that's just 2, equals 2 times the cube root of 1 is 1, so 2 equals 2, and that works out. So my answer is x equals 2. Now let's move on to the last example, number 4. Okay, our last example, this one looks a lot different, but it's the same thing really, okay? Alright, so let's look at this. If you'll remember in our first lesson on radicals that we talked about when we were adding and subtracting, we talked about x to the 1/2 power is the same thing as the square root of x. It's actually x to the first and then the square root of it. This is our power, this is our root. So if I had x to the 2/3, that would be x squared, and you take the cube root of it. Okay? But we're going to look at this part up here. Anything to the 1/2 power just means I can take the square root. So I can rewrite this problem as x plus 6, and I can make it square root instead of to the 1/2 power, minus the square root of 2x minus 4, and that's going to equal 0. Now I don't have this solved for one of the radicals, so we'll solve it for one of the radicals, and basically what I do is I just move one of them to the other side. So I'm going to add the square root of 2x minus 4 to both sides. Alright, and that leaves me with the square root of x plus 6 equals, now 0 plus that is just that. 0 goes away. This is the square root of 2x minus 4. Right, so now I've got this to where I can go ahead and raised to the second power, both sides, since it was already solved for square root. And that gives me x plus 6 equals 2x minus 4. And just solve this thing by doing your inverse operations.
Sorry, folks, a couple.
And that gives us negative x plus 6 equals negative 4. And then I subtract 6 from both sides. And that gives me negative, let's do it up here, negative x equals negative 10. And then divide by that negative 1. It gives us x equals 10. And then if I wanted to check it, I could take it and plug it in here. 10 plus 6 is 16. The square root of 16 is 4. 2 times 10 is 20 minus 4 is 16. Square root of 16 is 4. 4 minus 4 is 0. So you'd see it would come out correct. Okay? Hopefully you understood this. It seems pretty simple. But if not, just go back, rewind, listen a little bit more, and be prepared to ask any questions in class tomorrow. If you'll complete the WSQ for us, and be ready to work on some problems for this in class tomorrow. And don't forget, you'll also have a K-check in class, so be ready for that over yesterday's lesson. All right? Have a great evening. We'll see you tomorrow.